Okay, hello, good evening, I guess, to another session of C programming. Hope you all is doing well. Okay, so in the last video, we looked at iteration, right? How to repeat stuff over and over again. Okay. So I hope that was clear. If not, you can please post any comments you have, and I'll do well to respond to each and every one of them. Okay, so in this session, we'll be looking at inputs again. Now, the last inputs that we did, right, we looked at how to read inputs from the keyboard. This time around, the inputs that we'll be looking at will be based on files, right? How to read input from a file rather than the keyboard. Because if you think about it, most applications work that way. For example, if you're opening up maybe your favorite game, for example, it stores settings in files. So when you open it, the game will go and look in the file for the settings that you have saved and then apply them into the game, right? Okay, so without much ado, let's go to code blocks and then start today's session. Okay, so we'll be looking at, well, importance of file input. That's basically what we just talked about, right? It's just most of the time your data is already available in files, or sometimes it's a huge amount of data, something you can't possibly enter in the keyboard, and that is the reason you put them in the file and then process it, right? Okay, so that does it for the importance of files. Sorry. So let's just get into it. So because the whole concept of input, I assume that you understood it from the first one that we did, right? Okay, so let's start. How to open a file. Now, before we work with any file in a program, right, we have to make sure that the file exists on the computer's hard drive or some storage that you are reading from. If the file doesn't exist, you can't really have access. Then there's nothing to actually access, right? So I'll go over to where this particular file is stored in my computer, and then would create a file that would work with, right? So I'll create a new file, a text document. We'll call it I don't know, let's just call it files test. So files test.txt, that is the name of the file we are going to be using, right? So what we'll do is that we'll open this in Notepad and then edit it. So let's switch over to Notepad. Yeah, so we'll just put in some text inside, right? So I would say my name is Kwame. I am just a basic bio of myself. I'm 22 years of age. Right, so this is just something we are using to test this whole thing. So this is what I've saved in the files test.txt, right? So the first part of this, or when we get to the reading part, we'll simply take this file, open it, read all the inputs, and then print it out onto the console window, right? So let's see how we'll do that. So the first thing to do, like every other program, is to declare our variables, right? So now, since we are working with files, we have a special kind of variable that would declare. So you already have your, your data, your primitive data types, integers, floats, characters, right? But there are more advanced data type, and in this case, the file is one of them, right? So let's just declare, and then we'll explain what we've written. Okay, so this is a variable I'm calling file var. Is of type file star, right? So anytime you see this star attached to a data type, that means this is no longer a normal variable, but it's what we call a pointer variable, something that points. Pointers are something it's kind of a bit advanced stuff in C, but we'll talk about it in later videos. But just know that this is basically a file variable declaration, right? So we have the data type here, and then we have the variable name as well. Agreed. Okay, So let's just comment this as file data type or declaration, file variable declaration. So that's what we have over there, file var, that's the name. So what happens is that, or what will happen is that we'll use this to store something like a reference to the file that we want to work with, right? So it is through this variable that we are going to have access to the contents of the file. That's how you can think of these things, right? So the first thing we need to do even before reading the data is obviously to open the file. So because if you don't open the file, you can't really get what's inside. If you don't put on your machine, you can't get access to the content of the hard drive, right? Okay, so let's do that. So hopefully then this line should make sense to you, right? So we'll call it files test.txt, and then we'll put a second one with R, right? So this is basically opening the file. So that is how we initialize these file variables. We use an inbuilt function called fopen, right? So fopen is short for file open, but it's just like that's the name of the function, fopen. So anytime you see fopen, know that you want to open a file. Okay. So the first argument that it takes, right, is obviously the location of the file, right? So because these two, my C file and the txt file, are in the same folder, I've just written the name of the txt file, right? So don't forget the extension as well. And then the second part of it after the comma is the mode in which you want to open it in. So in this case, because I want to read data from the file, I'm using the read mode, which is denoted by R, right? So fopen takes the location and then the mode you want to open the file. So if you'd want to write data to the file, you'd use the mode W. If you want to append the data, there are kind of about 9 to 13 modes that exist, but you can read on them to see what each particular mode does, right? So this is basically how we open the file. So after the fopen is complete, it will return a reference to this variable, which is what we use to manipulate the file basically. Okay, so before we move on, let's talk about the location of the file first of all, right? So anytime we talk about the location of a file on your computer, we can refer to, or we have two types. The first one is what we call the relative location, right? And then the second one is called the absolute location, right? So let's talk about what relative location is. So if you hear the word relative, relative means with reference to something, right? So if you look at it, if I go back to the Explorer, you can see that this is my C file that I've opened in CodeBlocks right now, right? It is actually in the, if I go down the files test is also at the bottom here, right? So because these two are in the same folder, the address of the files, or the location of the files test.txt relative to my .c file, is just basically the name of this file because they're in the same location. So if it is looking for this file, all it needs to do is to check in this folder with one that has this name of files test.txt. I hope that makes sense, right? So let me just illustrate with another example to make it clear. So let's say I created a folder, I call it RES, short for resources. And then inside this folder, right, this is where I now create my let's say test dot or files test.txt, right? So because now the two of them are not in the same folder, that means if I'm here, I first have to get to RES, and then inside RES I find files.txt. So if that was the case, then if we go back to CodeBlocks, I will type something like res followed by / and then files.txt. So this is what we mean by relative location. So the location of this files test.txt relative to this C file I'm working with is res, meaning go to the res folder and then you look for a file called files.txt, right? So if it wasn't in the res like how we had originally, it means in the same folder this C file in, look for a file called files.txt. That's what we mean by relative location. So that means this is the location of this file relative to this C file, right? So that means relative to maybe a file in my drive X, this address is going to be different because the pivot point has now changed to another one or another file. So I hope that kind of makes sense. If relative address or location doesn't make too much sense, I'll post some links in the description to read more about them. Okay, so now we've talked about the relative addressing. Now let's talk about the absolute. So I'm going to delete this folder because I don't need it anymore. Let's talk about the absolute address, right? So now if we talk about absolute address, it simply means the one starting or the address as started from the beginning of your drive, which normally is the drive letter if you're using a Windows machine. So if you go to any folder, right, and you click on the address bar, you can see what I'm talking about. This starts from drive C, my users folder, my actual users folder, the documents, then we come to code blocks, and then this folder. This is the address of the folder that I'm currently in. So you can see with this, right, it is not really relative to anything. It is absolute because I'm starting from the beginning of the drive, which is a drive letter in a Windows case. If you were on a Mac or Linux machine, you normally start with something like this. So this / is the root drive, right? So that means no matter where I am in the hard disk, if I should take this address and paste it inside the address window, it is always going to open this folder because I am not relative to anything. I hope that also makes sense. So relative is relative to one file. Absolute means you are beginning from the drive, right? So there are times when you'd want to use absolute, but most of the time we use relative, in the sense that if you take this, right, this is my my user folder. On someone's computer, this will be different because he or she may be using a different name. So if I should use an absolute address of all this, that means if I should send my files to someone else's computer, it's not going to be able to find the address or the file that it's looking for, right? Because this doesn't exist. But since it is relative, that means if I put both of them probably in the same folder, it is actually going to pick it up. So that's mostly the advantage of using relative locations. Right. So like I said, I'll put some links in the description and then you can read more about them. Okay, so let's continue. So we've looked at the file variable, right? That its data type is the file star. So it is important that this is all caps because you know C is case sensitive, meaning doing this is not the same data type as what we had initially, right? So even if I try to run this, automatically I get an error. So it always has to be in capitals. Okay. So anytime you open a file in a file reference, you have to remember to close it. Most of the times it won't cause an issue, but there are certain times when if you forget to close it, it can mess up the content of the actual file. So if that is a critical file on the system, that means it's going to destroy it, right? Or corrupt it. So after we are done manipulating it, we will call the F. The same way we had F open, we also have F close. And then we pass in the file variable to it, and then it closes the reference to that file. So this is kind of similar to the way you do a safe removal of a pen drive from a PC. So when you finish, you click the safely remove devices and it takes the device out. So this is something similar. So it safely closes the reference so that we don't risk any file corruption, right? So anytime you open, you have to close it. So what I normally do is that anytime I write the F open, I put the F close there, and then I type everything in between so that I don't forget this. So that is basically it, right? So at this point, let's try running our program and see if there are any errors we need to fix. So if you run it, you can see that we still have some errors. So it says unknown type file. Oh, right. We forgot to include the stdio because the file exists in that particular header or names or header file. Yeah. So if you try running it now, you can see that it actually works. Right. So we have that. Okay. So don't forget to include your stdio.h. Okay, so we've seen how to open and close a file, right? Now let's get to the real part of why we are even using files, to read data from the files. Agreed? So if we should go back to our notepad, you can see that this is the content of the file. So what we want to do is to read all these lines and then print them out onto the console window, right? So let's see how we do that. So now if you are using files, you have access to a number of functions that can either read or write data, right? So we have the fscanf, which is similar to the way a normal scanf works, but for files. We have fgetc, fgets. I mean, there are so many. So you can do read on files on some resources, and then you get to know what each of the functions does. But what we want to do, the function we are going to use is a function that anytime you call it, it reads the next character in the file. So that means if we should call the function, first of all, it's going to read capital M. The next time we call it, it's going to read Y. The next time we call it, it's going to read a space. The next time you call it, it's going to read an N, and so on and so forth, till it gets to the end of the file, right? So that's the purpose, or that's the function that we'll be using. The function is called the fgetc. So you can see, yeah, that's the function fgetc. Right, so we'll see how we use it in a bit. So what we want to do is that we want to continuously read each character until we get to the end of the file, right? So because I want to repeat the task of reading a character, that means I have to put it in a loop. So iteration, what we did in the last video. Okay, so I'm going to say while true, right? So if you remember from the last video, while true is an infinite loop. So we will put our corresponding if statement or conditional statement inside to break it at a point. So that to use the true keyword, right, you have to include another library or another header file called the stdbool.h. So this gives you access to Boolean functions or variables like true and false also, right? Okay, so while true, so what do we want to do? We want to read the next character. So the function, you remember the function being called the fgetc. So the thing, what it takes as an argument or an input is the file reference, right? So fgetc, anytime you use it, it returns an integer, which is the code for the character that it has read. It doesn't actually give you the character. So if you read, for example, capital A, you get a code of 69. So when you cast that into a character, then we get the actual letter capital A, right? So don't forget that. So we need to break the loop at a point, or when fgetc reaches the end of the file, right? So one thing we should know is that anytime you use fgetc, if it should return a value of -1, that means it has actually reached the end of the file. So what we'll do is that after we read the next character, I will check if that next character, right, is equal to -1. If it is, then I can break the while loop. So you get it. Next character returns non-zero numbers for any non-negative numbers for any character it gets. So if it returns a -1, that means it has reached the end of the file and we can safely terminate there. Agreed? Okay. So now we need to print the character we've read. So remember, we said the f get C, right? It returns an integer, not a character. So let's prove that by actually printing out the integers for us to see, right? So this is basically how we would read from a file, right? First of all, declare your file variable, and then you open the actual file. So this is declaration and initialization. So you can also do all on the same line like this. It's still valid, right? So we'll still leave it as this. So remember, fopen takes in the location, either the relative or the absolute, and then the mode in which you want to write or you want to open the file. So in this case, a read mode. We are using the fgetC, which reads one character anytime you call it, and then we are storing its integer result in the variable next character. So we check if next character is equal to -1, which means that I've gotten to the end of the file. If it is, then we break. So if it is not, that means this if statement will be skipped entirely, right? Next, we print out the character. So we are printing out %d because I want to show you that it's actually an integer, right? So when this whole while loop ends, then we close the file. Right, so I hope the logic is clear. Okay, so let's run this and then see what we have. So if you go to our output, you can see, well, you can see things actually. These are numbers. So these numbers are the codes for what we are seeing or what we wrote in the notepad file, right? So now we will cast them into their corresponding characters and then print them out and see exactly what we get. Right, so let's do that. So in here, we are going to change this to a C. And then I'm going to cast my next character into a car variable, right? So now if we should run this again, you now see what we have in the file. So this is a simple example of file inputs, right? We wrote data into a file, we read the data from the file, and we put it in the program. Okay, so now there's one thing I forgot to mention. Anytime you call the fopen function, right, there are two things that can happen. Either it was able to open the file, or it wasn't able to open the file, right? So sometimes if you are trying to open a file whose location doesn't, or a file that simply doesn't exist, right? Obviously fopen is not going to open anything because it couldn't find anything. So another example of is that maybe you've opened the file but you don't have you are trying to open the file but you don't have permissions to actually open it. Then in that case the OS is not going to allow you to open it. So this function is also going to fail. So anytime we do this, we have to check if the file was actually opened before we perform any operations on it, right? So anytime you call fopen, you have to put a conditional statement to check if file was actually opened. So in that case, I check this. So that means if file var is equal to null, null means nothing basically. So if nothing is there, that means the file was not, or we couldn't open the file, right? So we'll just print out an error message. So an error occurred while opening the file, and then I return or I end the program. Or it might not always that you'd want to end the program. Maybe you want to continue with certain stuff, but in this case, since there's nothing else to do, we just end the program, right? So anytime you call fopen, so I think I'm just going to use this. I'm used to initialization declaration the same way. So anytime you open your, or you call the fopen, you check if the file is null or the variable is null. If it is, that means an error occurred and we couldn't open the file, and then I terminate here. If it's not null, that means it's going to skip this if statement and then come to execute this, right? So if we should run this, because it executed the first time, that means I didn't have any issues. So we have that, right? So now we'll do something here. What we'll do is that we'll go to our directory and then change the file name from here, right? And then we'll come around the program and see whether it works. So we are going to change it to just files.test. I'm removing the last T from there. So if we now come and run the program again, you can see that it's now behaving correctly. So because the file didn't exist, we can't, running that while loop wouldn't make sense because there's nothing to read from, and sometimes that might cause errors and a whole lot of stuff. So to be safe, if the file doesn't exist, just end the program, right? And then we continue. So that's what I was talking about. Okay. So that is how. Now remember, we just used one of the functions, fgetC. There are many functions that exist for files, or how to read data from files, right? So another one is one called fscanf. So this is similar to the way a normal scanf works, but it's for files, right? So let's see if we can get this video short, then I'll add an exercise to it, else I'll just put the exercise in the next video. So that's how we read data from a file, right? So let's look also how we write data to a file. So we'll just comment all this. Right? So let's just collapse it so that it doesn't get in the way. So we'll go back to our File Explorer and then would create another text file. So this time we'll call it write test.txt. So we'll leave it empty. The whole idea here is that we will use a program to populate that file instead of doing it ourselves, right? So that's how we write data to the file. So in this case, it will be in the point maybe where you want to save something. This is how you do it. So any program that has the ability to save, it is simply writing change or data to a file. So let's also see how that would be. What I was saying was we've written, or we've opened the file. First of all, we've checked if the file is null. If it is, then we print out our error message and then we return, right? So we use the fprintf command to write to the file. So the first input you send into it is the file you actually want to write into, and in this case is the file var. And like the normal printf statement, everything else is the same. So this one in the double quotation marks is what I actually want to be written to the file. So we are going to write this is a sample data to the file, right? So this fprintf writes the file, and then we printf a normal write successful onto the screen, and then we close the file, right? So if I switch over to the outputs, we can see that we have write successful. So now let's go to the let's open the file in Notepad and then see that the file has been written to actually. Right. So we have that. This is a sample data. So this is exactly what we wanted to write to the file, and then we've written it. So any application that has the ability to save, this is basically what it is doing. It's simply reading and writing to the file, right? So that is how we work with files. First, get your file variable, and then so you specify the location and then the mode, and then you can read and write to the file depending on the mode. So what we'll do is that this file is an especially tricky subject, so let's keep this video short. We'll do the actual example in the next video before we move on to the next topic, right? So I would recommend that you go and then start again if you don't really get it. So don't rush it, because files, I mean, if you get it to work, it's nice, but learning the concept is not so nice. The first time I was working with files, I had a whole lot of issues, but with practice, we've been able to master it of some sort. Right? So go through it again, look at how we did the reading, look at how we did the writing, right? And then try your hands on some things. So you can even, maybe you have your scores in an Excel file, you can read in the Excel file with the scores and then perform operations like this: average, sum, minimum, maximum. You can perform all that onto it, right? So go through this again, and if you still have any questions, please put them in the comment box and I'll do well to respond to each and every one of you. Okay, so I'll see you in the next video. Have a nice day and happy programming.